tacho generator. Now, when we people are saying the generator is the opposite terminology that will generate either DC output, or either it will generate a AC voltage, DC voltage or AC voltage. Now, here we are having motor. So for motor, what we people are providing as an input, we are providing electrical supply as an input, and that electrical supply is used to generate the motion of uh, uh, motor. Whereas in a generator, actually it is reverse to that of the motor. So what is going to happen when we people are trying to provide the input as a motion? Now the input as a motion, depending upon that, it is going to generate the output. Here your concept will be clear that I am saying this is electrical type of tachometer, means when we people are generating the output is in terms of electrical form. In previous case, the output is generated in terms of current, that is ED current, and here the output is generated in terms of voltage. It may be your direct voltage, or it may be your uh, alternating voltage. Okay, direct current or alternating current generator. But the mean of generation of the output is nothing but the input is motion, and based upon that motion the output is generated. Now if your motion is less, the output generated will be less. It may be AC or it may be DC. And if your input is more, at that time output generated will also be more. The same fundamental is used to generate or to retrieve the information of the speed depending upon the motion. So it consists of a small magnet type, either DC or AC generators, that translate your rotational speed, that I have said motion. Motion means rotational speed into the output as a DC or AC. So to convert the DC output in terms of, we people are using the rectifier bridges, and that rectifier bridges is going to convert the output in alternating form, that you people have studied in basic electronics. So I will not go in that much depth, but for your understanding, either you can use a half wave rectifier or full wave rectifier to convert it. I will show that particular circuitry also in this presentation. Okay. So relative perpendicular motion between the magnetic field and the conductor results in generation of voltage in the conductor. Okay. So this is the principle that is used, because here your perpendicular motion between what? Magnetic field and conductor, that results in the generation of voltage. So I will show that diagram also when we are switching towards that tacho generators, or your AC or DC generators. Specifically, we are going to study that. So the magnitude of this voltage is a direct function of the strength of magnetic field, and strength of magnetic field is totally depend upon the rotation or motion of the speed with which your conductor moves. It is in perpendicular to it. So DC tacho generator. In DC tacho generator, the EMF is nothing but the voltage generated depends upon the following points. What are the following points? That is the field excitation, that we people are going to keep it fixed one. Field excitation means input which we are going to provide to it. And second one is the speed. Here we people are interested to measure the speed, means we are going to vary the speed, and this speed is going to provide you the output in terms of voltage that can be calibrated in terms of speed. as you go on, because whatever input speed you are going to provide, that is unknown to you and you are interested to measure that. So over here, if for the field system, permanent magnet, two permanent magnets. What are the permanent magnets? These are the two permanent magnets. And over here, here is your shaft. So this shaft is rotating. Here is the permanent magnet, and you people can try to measure the output of the armature with help of this one, depending upon the variation in the speed that I will show you. Hence, the speed can be computed by measuring the generated EMF due to the rotation of the shaft or that particular armature. So, the shaft whose speed is to be measured is coupled with the armature. It is coupled with the armature, and a moving coil voltmeter is connected across the brush, because actually DC tacho generators or DC motors are having that limitations of the loss due to the brushes that are present to measure the generated voltage. The variable resistance R is incorporated to limit the current. What it specifies, that variable resistance in the path, variable resistance in the path incorporate, that is utilized to limit the current, through the voltmeter that I will show you people. Since voltage is proportional to the speed, the voltmeter may be calibrated in terms of speed. What he says, the voltage is proportional to speed. Whatever the output voltage, whatever I am telling to you people, if that voltage is proportional to speed, the voltmeter with help of which we people are measuring the voltage that is generated due to the speed, that voltmeter is calibrated in terms of speed, that is nothing but RPM. This is the structure. So if you try to visualize that these are nothing but, these are permanent magnets. Here is the coil, or that what we people are saying, that rotating magnetic mean, and across this one, here we people are measuring the output in terms of voltage. Here we people are measuring the output in terms of voltage. This is the brush. This is the variable resistance that we people have used. This will limit the current. Current I will specify as I. So it is going to limit the current and voltage in the path. Now across the brush, we people are trying to measure the resultant output. So when this armature is rotating, this is the rotating shaft, this is continuously rotating, armature is connected over here. So when this armature is rotating and this one is the permanent one, so it will try to generate the resultant output in terms of voltage depending upon the speed. Yes. So the output which is generated, that output is measured using your this one. It is measured using this voltmeter. So this voltmeter will reflect, moving coil voltmeter, that will reflect your resultant output. Okay. And that output is calibrated in terms of RPM, as I have specified earlier. So this is, you people are getting the direct output through this one. That's why it is DC tacho generator. Now AC tacho generator, alternating. Now there is a limitation, as I have already told you, there are limitations or demerits associated with your DC tachometer or DC tachometer generator due to the provision of the commutator and brushes are eliminated in AC tacho generator. Now here your commutators and brushes are eliminated in AC. So it consists of like an alternator. It is working as an alternator. It consists a stationary armature that is called as a stator. In motor also, you people may have studied in electrical one. There is a stator, there is a rotor. And here also, we people are having a stationary armature and rotor field system, that is stator and rotor. Stator and rotor. So over here, we people are having stator and rotor. Owing to this generation of EMF in a stationary coil on a stator, commutation problem no longer exists. So that particular problem of commutation is resolved or is solved, which was present in your DC tacho generator. The alternating EMF which is induced in the stationary coil is rectified in your AC one, and the output DC voltage is measured with the help of moving coil voltmeter. That we people will go in detail in the next slide, or that structure I will show. The ripple contents of the rectified voltage is a smooth by the capacitor. Why the capacitor is used? Because whatever the ripples, what is the ripples? Suppose I am having the output. So this is nothing but this is the output actually which is generated. And here is one me. I am interested to measure the resultant output. If suppose this is the output which is generated, these are nothing but these are the ripples. If you try to observe these one, these are nothing but these are the ripples. Actually, these ripples are not a good sign of a generation. We people are interested to have, if suppose this is my x-axis and this is my y-axis, I am interested to have the resultant output like this, not these ripples which I am showing with a red one. These are the ripples. They are continuous. They are not good signs. So actually, using the capacitor filter, these ripples are rectified or they are suppressed, so that you people are going to get the smooth output. So over here, you people may get the resultant output like this smooth one. Here I am getting some reflection while drawing, but you are not going to get the ripples using that particular aspect. And that can be overcome by, or that can be smoothened by using your capacitor filter. As speed depend on both amplitude, speed depend upon both amplitude, this is the amplitude of the voltage, and frequency and frequency. So at one axis you people can measure amplitude, and another axis you people can measure the frequency. Any one of them can be used. Either you can use a voltage amplitude, or either you can use a frequency, can be used as a measure of the speed. In a AC tachometer, it is the induced voltage, actually induced voltage, that is considered as a required parameter, because it is electrical type of speed measuring device. So here your mean which we people are using is induced voltage due to the motion. So here we people are having the rotor. Here we people are having the stator. The output of the rotor is connected to the rectifier via the current limiting mean. And here if you try to observe, here for the rectification purpose, for smoothing of the ripples, the capacitor is incorporated in the path. So the output generated will be measured across the output generated